Hello, it's Scott Manley here. This is the Space Shuttle Enterprise, making what is the worst landing of its career, and many would argue the worst landing by any space shuttle. Piloted by Fred Hayes and Gordon Fullerton, this would be the final flight of the approach and landing test program and the first landing of a space shuttle on a hard concrete runway, and they did it in front of assembled dignitaries from around the world, including Prince Charles of the United Kingdom. What happens is there's a bit of a wobble and then a bounce, and they're back in the air, a little more wobbling back and forth before it finally settles down and lands a little skew whiff on the runway. Despite all these shenanigans, they still managed to put the shuttle down with only 7,000 feet of runway. They had been allotted 10,000 for this demonstration. The program was considered a success, and there would be no more purely atmospheric test flights. This would be the last flight of the Space Shuttle Enterprise. The first space shuttle to fly was revealed in 1976. Given that this was the 200th anniversary of the Declaration of Independence, it was thought that this would be called the Constitution. But a letter-writing campaign by fans of Star Trek got the name changed to Enterprise to reflect the spacecraft from the TV show, and there were members of the cast at the rollout. Ironically, however, Space Shuttle Enterprise would be the one space shuttle that didn't go to space. Enterprise was built as a test vehicle. It had all the correct structural elements in place, it had roughly the right mass distribution, it had working wheels and wings and control surfaces, but its first job was going to be to verify the aerodynamic behavior of the space shuttle, and for that it didn't need to have working engines. It didn't need the reaction control thrusters or a fully kitted out payload bay, and it also didn't need a working thermal protection system. The tiles which are on Enterprise are made of polyurethane foam. They're roughly the right density and the right dimensions, but they certainly wouldn't help you through re-entry. Enterprise did have one feature that was missing from the other shuttles, this long aerodynamic probe which extended out beyond the nose. This was because it was a test vehicle and they were needing to calibrate the onboard aerodynamic instruments, and to do that you have a sensor which sticks out beyond the front of the aircraft before the air gets messed up by the airflow around the vehicle. Enterprise would also be the only shuttle to actually fly with the aerodynamic tail cone attached. But long before the space shuttle could take flight or even finish its design, they were testing models of the shuttle in wind tunnels, some as large as 1/3 the size of the real thing. They tested it across all sorts of speed ranges, even up into hypersonic speeds. And of course they had to test the vehicle when it was mated to its external tank and boosters. Enterprise would of course never fly with the external tank and boosters, but it would fly on top of the shuttle carrier aircraft, and they needed to know that this would work. The shuttle carrier aircraft was a converted 747. It had dorsal mounting points, allowing a space shuttle to be carried on its back, and because the airflow from the shuttle would interfere with the operation of the regular tailplane, it had an extra wide horizontal stabilizer with extra fins on it to allow the vehicle to actually control itself. The carrier aircraft was going to be an integral part of the space shuttle program because they needed the carrier to be able to move the space shuttle between its landing sites, which might be on the west coast, to a launch site that might be on the east coast. And initially it was very much an experimental aircraft in its own right. They performed a lot of tests just to make sure that the 747 was safe to fly with this extra aircraft riding piggyback on its structure. This test program with Enterprise was carried out in 1977 at Edwards Air Force Base, and after demonstrating that they could taxi and roll down the runway at speed, they eventually took to flight, and they carried out a series of 5 cold tests where the space shuttle was inert and its control surfaces locked into place. Now, this showed them a lot about the vehicle. In particular, it showed that there was a decent amount of turbulence due to the air shedding off of the space shuttle on top of the 747. Having demonstrated the airworthiness of the shuttle carrier with an inert shuttle, they proceeded to the captive-active phase, where there would be astronauts on board and the shuttle systems would be running.
generating power and cooling, including the power that's needed for the all-important flight computers, because the Space Shuttle was very much a fly-by-wire vehicle that had 5 computers on board. It had 4 that would work by voting each other out, and it had a final backup computer which would be able to perform if they had lost everything else. The Space Shuttle wasn't passively stable, so it needed a fly-by-wire system to keep it stable and controllable by astronauts during the descent. The astronaut test pilots would also train in shuttle training aircraft that had been modified to give them similar performance to the Space Shuttle. They took a Gulfstream II jet, they added extra drag surfaces, and then put the engines into reverse, and that turned a high-performance business jet into a flying manhole cover. The left side pilot seat was modified to have the same controls as the Space Shuttle, whereas the right co-pilot side maintained the original controls in case there was some situation that required them. They also had a simulator that they could train on before they flew the real thing. And of course, since this was the mid-1970s, the cockpit views were generated by a camera moving over a model of the terrain surrounding Edwards Air Force Base, since they didn't have the computer graphic capabilities in that era. So with all this preparation under their belt, the first free flight of the Space Shuttle Enterprise was to be on August 12th, 1977. The test pilots for the first flight would be Fred Hayes, who had previously flown on Apollo 13, and Gordon Fullerton, who would go on to fly on STS-3. A critical part of this test was where the 2 aircraft had to separate. Now, this would be initiated by the carrier aircraft beginning to go into a dive and picking up enough speed that the Enterprise could get lift. But if you think about it, the Enterprise had very small wings, whereas the carrier aircraft had much larger wings. So to achieve separation, they needed to have very different angles of attack, and that's why the forward pylons were about 2 meters longer compared to when the carrier aircraft was used for transporting the shuttles across the country. So separation occurred at an altitude of about 25,000 feet and a speed of about 310 miles per hour or 500 kilometers per hour. The separation is performed by explosive bolts, and as soon as that was triggered, the vehicles began to move apart. However, the shock of the exploding bolts caused a glitch in one of the computers which had bad soldering. That was computer number 2, but of course computers 1, 3 and 4 voted off the line and the vehicle continues to fly. So while that was a bit of a black mark against the computer hardware, it was definitely a big plus demonstrating the redundancy of the system. Immediately after the separation, the plan was that the shuttle would turn to the right and the carrier aircraft would turn to the left. And after that, the pilots had a job of basically performing their test flight. They only had a few minutes before they would land because the shuttle was not a great glider. But they were able to run their controls through various configurations, sweep their attitudes and their control surfaces orientations, and then they set the thing up for an automatic landing because they were testing an automatic landing system. The computer was supposed to handle this and put it down on the runway. Their job was just to make sure that it flew correctly and, of course, to push the button to drop the landing gear as it descended towards the lake bed at Edwards Air Force Base. So that was the first of 5 successful approach and landing tests. 3 of the tests would be carried out by Fred Hayes and Gordon Fullerton, and 2 would be carried out by Joe Engel and Dick Truly. So for test 3, they dropped the speed a bit, and then for test 4, they removed the cone off the back to increase the aerodynamic drag, and as a result of that, the separation speed was lower, which is why they tested with the lower speed on number 3. But test number 5, that was the one where they were aiming to show that they could actually hit a concrete runway. And the flight went very well right up until a few seconds before touchdown, and you can actually listen to the onboard audio.
240. 230. Come on down, Mitch. 210. 200. Real good speed. Shit. Okay, we're back. Okay. Watch it. Let the stick go. Hold it. Jesus. Oh, shit. Put her down. Speed brakes out. We're 130. Get the nose on. Okay, we're in direct.
So yeah, a lot of you are hearing the salty language there because the pilot was having a fairly hard time keeping things under control. This is a perfect example of a pilot-induced oscillation, but it wasn't entirely the pilot's fault. The computer was getting behind, and the immediate solution to the problem was the co-pilot's suggestion to just let the stick go, let the computer catch up, stabilize things. But after the landing, they spent a lot of time analyzing this and optimizing the computer and understanding that there were problems. For example, unlike many aircraft, the Space Shuttle had a set of elevons, and these would control pitch and roll. The fly-by-wire system placed a higher priority on pitch control over roll control. So when there was a lot of control inputs coming in, the pitch would end up getting rate limited and delayed. And that changed the vehicle behavior over what the pilots had learned, and that served to amplify or exaggerate the pilot-induced oscillation. To refine the fly-by-wire system, they used the Digital Fly-by-Wire project, which was an F-8 Crusader which had been converted and its flight system replaced with a fly-by-wire system that used the Apollo guidance computer. You can actually see the disky display there in the side of the aircraft. Neil Armstrong was a huge fan of this project and promoted it. So they were able to adjust the control laws between flights so that they could introduce delays or rate limits and see how the pilots responded. They were able to model the conditions or determine the conditions under which pilots were most likely to introduce the oscillations and figure out ways of adding dampening, which would also allow rapid control response. The software was rebuilt and tested on this test vehicle without the shuttle being needed. So the next time that a computer with this software flew on a shuttle was STS-1 when Columbia made its maiden voyage to space. And there were many technical problems on that flight, but the flight software for the landing was not one of them. But the Space Shuttle was still very much an experimental vehicle at this point, and its fly-by-wire system did continue to evolve. On STS-3, there was a rather dramatic landing. The automatic landing system was still very much in development at this point, and they left it on longer, partly because they were interested in finding out the bugs in it, but it ended up messing around with the speed brake, opening and closing it more than it should. They brought the front nose gear down, and then moments later decided, no, we're actually going too fast, and they raised the nose gear back up before then finally putting it down on the runway. Charles Bolden, who had worked on the auto-landing system, said that this saved the shuttle. And while the test program with Columbia continued, Enterprise, the shuttle named after a fictional spaceship, never got the chance to go to space. The original plan had been to send it back to the factory, strip it down, and then rebuild it into a fully functioning orbiter. But that never happened, because it was very quickly realized that there was a structural test article which could be just have the stuff added instead of having to strip it down first. So Enterprise became the shuttle that was moved around and used for fit checks. It was taken out to Vandenberg, and they verified that a shuttle could move down the road that they had graded and cut out of the hillside. They put it on side of rockets to make sure that it could fit on the booster stack, to make sure that the handling tools were all there. But then in 1986, after the Challenger disaster, NASA was looking for another shuttle, and there was a serious look given to upgrading Enterprise again. But once again, it was realized that there were spare parts that would be a lot faster and easier to use. So Enterprise continued to be this non-flying space shuttle. It was put on display at the Smithsonian, and then after the Space Shuttle program ended, it was replaced by Discovery, and Enterprise moved to the Intrepid in New York, and that's where it is today. But remember, all those other actual space shuttles, they were able to land because of Enterprise, because Enterprise had gone to places in the flight envelope that no shuttle had gone before. I'm Scott Manley. Fly safe.